In this series of videos, I'm going to go through naming chemical compounds. So in this video, I'm going to start by going over how ionic binary compounds are named. But before I do that, let's first look at the periodic table. Okay, so the periodic table is fairly important in all aspects of chemistry. And it's also important to refer to it when naming chemicals. So I'm going to start by looking at the structure of the periodic table. So the columns are called groups. Okay, so this would be the first group, second group, third group, etc. Fourth group, fifth. Okay, so there are 18 groups, and the rows. Okay, so the rows are called periods. Okay, and so what's important, what you need to consider when naming is the charges that elements can take on. So in their ionic form, elements from this group have a charge of +1. Okay, and elements from group 2 have a charge of +2. Okay, now here in the middle we have transition metals. They don't really follow a trend. Okay, so we skip this block, we skip the transition metals, and we go on to this group here. So this so group 13 has so these elements in ionic form will have a charge of +3. These will have a charge of, usually will have a charge of +4. Okay, but the charges do vary. Okay, now these ones here usually have a charge of -3. Okay, these ones, so group 16, have a charge of -2, and that's because they need to gain 2 electrons to have a full octet. And then this group here, the halogens, have a charge of -1, and that's because they gain 1 electron in order to they need 1 electron, and they gain 1 electron, and then they fulfill a full octet. Okay, and so the noble gases, so this group here, they're generally not involved in bonding, and so they have a charge of 0. Okay, so it's important to, when trying to determine the chemical formula from a name, it's important to consider the charges that elements can have. So let's go on to naming binary ionic compounds. Okay, so when naming binary ionic compounds, so that means generally they have only 2 elements in them. Okay, so 2 different elements in them. So something like sodium chloride, for example, NaCl. It has sodium in it, and it has chlorine in it. So when naming them, the way we do that is first we write the name of the first metal. Okay, so in an ionic compound you have a metal and a non-metal. Okay, so we write the name of the metal first, and then the non-metal second. The non-metal name ends in an "ide". Okay, so for example, fluorine becomes fluoride, and oxygen becomes oxide. The first letter of each name should be lowercase. Okay, so when naming, we generally don't use capital letters. Now these names are this naming convention was created by a committee, and so they're known as IUPAC. Okay, and so IUPAC stands for the International Union of Pure and Applied Chemistry. Okay, and so it's a federation, and this federation decided on a certain naming convention. So I'm going to start by naming these. Okay, so let's go through them. So pick a pen here, color. Okay, I'll pick this one. So let's have a look. So magnesium, so MgCl2. Okay, so Mg is magnesium. And so we would write magnesium okay, and then chloride. Okay, so instead of writing chlorine, we change the ending to "ide." Okay, and then the next one, sodium. So we have NaCl, so sodium chloride. Okay, so sodium chloride. Okay, next one, LiF, that's lithium. So writing the metal first, and then the non-metal, fluoride. Okay, CaBr2, so that's calcium bromide. And then K2O, potassium oxide. BeS, beryllium sulfide. Ba, barium. So when naming, make sure you refer to the periodic table. So if you don't know that Ba is barium, you just refer to the periodic table. So because the periodic table has the names for each symbol. Okay, so barium iodide. Okay, so when naming, make sure you refer to the periodic table so that you can find out what the name of each symbol is. Okay, so let's move on to now writing chemical formulas. So we're given the name, the IUPAC name, and we now have to write the chemical formula. So once again, you have to write the metal first and non-metal second, but in this case now you're going to be using symbols. You have to consider the charge that each atom can have and cross over the charges to get the subscripts. Okay? So for example, if we have something like, let's say we have Mg Cl. Okay, so we have we know it's magnesium chloride. Okay, so what we do first is we write Mg and we write Cl. Okay, now we have to look at the periodic table, and if you look at the periodic table, Mg is in the second group. Okay, and so you have to remember that the second group, elements in the second group will have a charge of +2. Okay, and chlorine, okay, chlorine is in this 17th group. Okay, so right before the noble gases. And you have to remember that elements in the 17th group have a charge of -1. Okay, so now what we're going to do is so first you can write the charges on top, and then what we do is we cross over. Okay, so this number here is going to cross over and go there, and the +2 is going to cross over and go, okay, after the Cl. And so what we're going to end up with is we're going to get Mg, and we don't actually need to write a 1. Okay, so if it's Mg, we're assuming there's 1. So MgCl2. Okay, so that would be magnesium chloride. Okay, so 1 magnesium and two chlorines attached to it. Okay, so now let's look at this one. So lithium oxide. Okay, so lithium has a charge of +1 because it's in the first group. It's an alkali metal. And oxygen, okay, so oxygen is in the 16th group. It is likely to have a charge of -2. Okay, and so what we want the charges to balance. Okay, because the compound itself is going to be neutral. Okay, so just like here we had, the magnesium had a charge of +2, so we needed 2 chlorines, each having a charge of -1 to balance this +2 charge. Okay, so I'm going to start by writing lithium. Okay, so Li is the symbol for it. And in this case, since lithium has a +1 charge and oxygen has a -2 charge, when we cross over, the lithium is going to get a subscript of 2, and the oxygen is just going to have a subscript of 1. Okay, so it's going to be Li2O. Okay, going on to the next one, potassium oxide. So potassium is in the first group, so it has a charge of +1. And iodide is in the 17th group. It has a charge of -1. Okay, so when we cross over, it's fairly simple. They both just will have a subscript of 1, so we don't even have to put the subscripts. So we're just going to get Ki. Okay, that's the chemical formula. Calcium chloride. Calcium has a charge of +2 because it's in the second group. Chloride has a charge of -1. It's in the same group as iodide, so it has a charge of -1. So when we cross over, the calcium is going to get the charge from the chloride, so it's going to get a subscript of 1, and this the charge from the calcium is going to determine the subscript for chlorine. Okay, so we're going to have Ca, so that's the symbol for calcium, and we're going to have 2 chlorines. Okay, now for sodium carbide, so sodium is in the first group. Okay, it has a charge of +1. Okay, and carbon, so carbon's a little bit tricky. Okay, so carbon can have different charges. So if I go back to the periodic table and look at this, so if we look at carbon, it says that carbon can have a charge of +4, okay, or a charge of -4. Okay, so in this case, since sodium has to have a charge of +1, carbon will have to have a negative charge, so it's going to have a charge of -4. Okay, so crossing over, so I'm gonna write this actually over here. So if I have sodium and it has a charge of +1, and then I have carbon that will need to have a charge of -4, and I cross over, okay, what I'm going to end up with is I'm going to get Na4 C. Okay, this is yeah, kind of a rare compound. It's not very common. You don't really see it that often. Okay, so Na4C. Going on to magnesium fluoride. So magnesium has a charge of 2. Fluorine has a charge of -1. So we're going to get MgF2. And then going to cesium sulfide. So cesium, take a look at where it is. So cesium is group 1. Okay, so CS. So it has a charge of +1. So, and sulfide has a charge of -2. Okay, so the cesium is going to get a subscript of 2. Okay, sulfide is going to go here. Strontium phosphide. So strontium is Sr. It has a charge of +2. So if we go to the periodic table, if we look at where strontium is, okay, so it's in group 2 over here. So +2 charge. So it's going to be, so it has a +2 charge. And phosphorus, okay, phosphorus, so if we go back to the periodic table and we find phosphorus can have a lot of different charges. It can have +5, +3, or -3. Okay, so in this case, definitely can be +3 or +5, because the strontium has to have a charge of +2, right? So it has to be -3. Okay, so the phosphorus will have a charge of -3. So let's write that out here. So if we have strontium, okay, so strontium has a charge of +2, and phosphorus, P, has a charge of -3. And if we cross them over, okay, so crossing over the charges to get the subscripts, the 3 would go here, and the 2 would go there. And so what we get, and I'm just going to write it here, is we're going to get Cr3 and P2. Okay, so Cr3. Right, so this is not working very well. Okay, Cr3 and P2. Okay. Alright, so in the next video, I'm going to go over how we would name molecular compounds. So compounds that don't have metals in them. Okay, so thank you for watching. If you found this video helpful, please give it a like and subscribe to my channel.